So first I will go the basic rules and then we will move on to the topic. Same actually, but yeah, we will move on slide by slide. Yeah. Sorry, don't mind about the unit 2. That's from my other institute. Let's go back to, here we go. Chemical equation. Actually, we know that this is actually shorthand representation of chemical reaction, correct? For example, if we see here the silver and hydrogen sulfide reacting together to chemical and producing silver sulfide and hydrogen. The way now I am telling the sentence, it's not convenient to do the practice or writing in a note and express more easily, more quickly. That's why these chemical equation terms evolve. So here we know the left side part we call the reactant and the right side part, mainly the arrow to right, is called the product. I hope you know. And we also sometimes see the different symbol. When it will come, I will describe it once again. I know it will be maybe review, however. Now the thing is that what are this number? Anybody know what are this number?
That would just be how many of the compounds there actually is, or molecules.
Yeah, how many of the element we have in the both side of the reaction, and this is called coefficient. So today we will learn how we can fluently do this balancing and actually why we need this balancing. Reactants, the chemical you start with before the reaction, and normally it have in the left side. Product, the new chemicals formed by the reaction, and in general right side of the equation. I'm telling in general because you maybe see there are also some reaction the both side arrow, correct? Those type of reaction actually called the reversible reaction. So only arrow to the right is not the universal. So that's why this is the in general or usual form, but not the all about it. So yeah, just to make sure. So now subscript. Subscript shows how many atoms of an element are in a molecule. For example, H2O, this is the water molecules. So here we can see that H2O, 2 is the subscript. That explains that you have 2 hydrogen atoms, correct? And we have no subscript. That means this represents 1 oxygen atom. Coefficient shows how many molecules there are of a particular chemical. So like how many moles or molecules. So here water means nothing we have in the left. That means this is 1 mole or 1 molecules of water. If we have 3, that this coefficient represents the 3 moles of water. By counting the coefficient, actually we can also have the quantitative idea to calculate the amount of each reagent we need to start the reaction and how much or how many in gram or kilogram we are getting the new product. So coefficient actually tells us lots of information about the chemical reactions. This is a chemical reaction, that's a hydrogen plus oxygen mixed together, combination type of reaction and produce the water. We could see here that we need 2 molecules of hydrogen and 1 molecules of oxygen that forms the 2 molecules of water. Now, if you start your reaction with the 1 molecule of hydrogen and oxygen, this reaction will not be pop up. So that's the things. Let's see the why we need this number. All based on this law of conservation of mass or law of mass of conservation. in this universe, like thermodynamics, when you guys will go to the up, like second year, third year, or whatever you have a major, you need more chemistry courses, especially if your major is chemistry or biochemistry. So you will that time studying the thermodynamics. There is one thing, the energy, that nothing is created or not is destroyed in the world, just change from one to another. Now maybe in this room AC is running, so this hot air are not vanishing, just the room hot air going outside, correct? So from one place to another. So in the chemical reaction also same. The reaction, or how to say that, due to the chemical reaction, maybe one product to new product is forming, but the actual number of elements in the reactant on left side or right side of the reaction is actually same. And this balancing of equation actually the evidence of that. That whatever the chemical reaction we do, maybe we will find the new product, but actually the number of each element, ingredient, are the same number. So that is the thing we say here, that in a chemical reaction, matter is neither created nor destroyed. In other words, the number and type of atoms going into a reaction must be the same as the number and type of atoms coming out. So that means the left and right side we are going to see. If an equation obey the law of conservation, then it is balanced. So now you can ask that, is it all the chemical reactions follow this rule? 99.9% follow this rule, but still we have some exception that already discovered, especially the nuclear bomb or something like that, that does not follow the law of mass of conservations. But the thing is that if 99% follow, so that is the exception, not counted, correct? So normally this is our rule and we will follow it. Now you can see here the one reaction, that methane plus oxygen produce the carbon dioxide, and this is called the water. Now how we need to start to balance the reaction, and what does it mean by balancing the reaction? Balancing means, let's do that here. That's fine. Okay, balancing mean, you can see in this molecule methane, one carbon and 4 hydrogen, correct? Here we could see the 2 oxygen atom. But in the right side, it is true that we have carbon, hydrogen, oxygen that produce the new compound carbon dioxide plus water. But we have our job to make sure that each number of atom or element in the left side and the right side are same or not. That is actually the principle behind the balancing. If we don't have, we need to do that. So now if we look into this reaction in the reactant side, let's see that how many carbon we have. We have 1 carbon, we have 2 oxygen, and we have 4 hydrogen. Now if we count, the number of carbon is same on the right side too. But oxygen, we have 2 here and we have 1 here, correct? So that we have to be count. And if we now you talk that, Professor, I just saw the oxygen in one molecule as a oxygen in the left. So do I have to count the oxygen that we have in different molecule? Yes. How many molecules you will produce by the chemical reaction? You have to add all the oxygen molecules. So here we have 2 and here we have 1. So we have 3 oxygen molecules. Is it then same? No, it is not same. So what we have to do? We have to make it same. And for that reason, we have to use the number. You have liberation to use the number 1, 2, 3, 4, 5, 6, 7, 8, whatever. But try to make sure not to use the fraction type, because chemists or scientists don't like fraction, because fraction bother you for your calculation the amount in the letter. So we also have that rule we are going to talk, but let's first do that, how then we can balance this type of reaction. Now if we look into here, that anyway, we have to make it the same number here. So first of all, the tricks I'm going to tell you, never going to balance the number that is alone. Alone means like diatomic molecules or any other, because any type of number in the end you can add here and make it balance. So now the thing is that we have a 4 hydrogen here, we have a 2 hydrogen, correct? So in my case, I'm not sure that I will able to balance, but I want to do that. What I want to do that, I want to add 2 here. If I want to add 2 here, now what, let's change the color. That will be good to understand. Okay, so now I'm going to clear the annotations, and again I will start with this color. So you guys now got it that what now we have to do that. Okay, so now here I will add 2. Here writing is little difficult, don't mind it. So if I add here the 2 water, then how many now hydrogen we have here? We have 4 hydrogen here. In the same time, don't forget to multiply the amount with other atom, correct? So then we have also 2 oxygen here, atom, not molecule. So then 2 plus 2, these 2 and these 2 now will be 4 oxygen atom. Then what we have to do? Now I have 4 oxygen atoms. So let's make it the 4 oxygen here. How we can do that? We have to multiply with 2. Then what is going here? We have now 4 oxygen in the left side too. Now let's count the carbon. How many carbon we have? 1 and 1. So don't you think that this reaction now seems the balance reaction? Balancing means that each number of element in the left and right side must be the same. Because this is the law of mass of conservation, and we have to follow it. We cannot go outside the box or outside the rule of mass of conservation. So if we guys got this one, then let's move on. Yeah, actually this is the balancing. Now you guys can ask that, Professor, this is very simple. There are so many complex balancing of reaction. It's okay. That without the complex, maybe it will take little more time. And you guys at the beginning, what you guys job to do, take your pencil and do it. First of all, never mind that I have to success in the first trial. Maybe first time you will think that, okay, I will go oxygen or I will carbon. Maybe it will not work. You will count, then you will again try. So beginning of couple of practice, you will see that it is taking time. But if you keep patient and keep doing, later you will think that the mistake is so easy, because when you will practice, you will find by yourself the technique. So then you will find it interesting, like a playing of the puzzle or Lego, just like of that. Here are some basic rules that can, that can show your path how to balance your reaction when you do. That can help you to save your time and do your job easily. So as we know, the matter cannot be created or destroyed. Subscript cannot be edited, removed, or changed. So whatever the subscript in the chemical reaction in the left side and the right side we have, we cannot touch there. And you can only change the coefficient. Yes, this is the only one thing we can do that. Coefficient can only go in front of the chem. That we write the left side of the molecules. A few extra tips. Balancing big formula first. As I said, that big formula means like the molecules or compound. Never try to balance the free element. Free means the nitrogen, oxygen, hydrogen, or even the water, that most of the time we see along with the chemical reaction. Because if you have only oxygen, any kind of number you can multiply in the end and make it the number same, right? So never try to balance the complex simple diatomic molecules are first. First try to be balance the big formula like polyatomic any molecules or something. If the same polyatomic ion appears on the both side of the equation, it is usually okay to treat as the one unit. Yeah, this one we will be coming. What I want to show you something. Let's see the phosphate group, polyatomic atom, ion or group, whatever. So you have in the left side phosphate. Don't mind about the writing, okay? It's very difficult to write with the mouse. And right side you also have phosphate, but maybe the metal, this is different from left and right side. There are two ways. You can count as a single element, or even you can consider as a whole polyatomic ion as a group if this is the both sides, correct? In that case, and if the group is broken, then you have to be then think about the single element. But as long as you have the same group in the left or right side with the other metal or something else, you can treat as a single unit. That will save your time when you will balance your chemical reaction. Yes.
Can we go back to the last slide?
Yes.
I was just curious. I'm not sure if I'm missing something in
Mm-hmm.
terms of the equation.
Okay. Yes, I will go back. Just give me the last point here. Okay. Yeah. So there is no one particular way to balance the equation, and this is final. I mean, there is no specific way that you can, because you will find different types of chemical reactions, but basic is the same, that the number of each element should be the same in the left and right side, and you can just change the number of coefficient as on the basis of your need. Let's go back. Okay, this one.
Yeah.
Okay.
So I thought that at the end,
Mhm.
those two technically have.
Here?
Okay. Never mind. I misread. Never mind. I'm sorry.
No.
That makes sense now. I just.
You
read
find it
wrong.
now? That this chemical reaction now representing that one molecules of methane react with two molecules of oxygen and produce one molecule of carbon dioxide and two molecules of water. But remember, when you will have the same element in the more than one molecules of compound, you have to count those elements and you have to add it. But when you add in the coefficient in front of any molecules, you have to multiply that coefficient to each element of the molecule, because this is somehow beginner student get confused. So yeah, so let's proceed on. Maybe it will make you more clear, and we will have some practice also. So here we go, the another example. And I also want to tell you guys that if you guys are beginner, that is still not so much clear and you have scary things, so follow this format, okay? Follow this format on your paper and page. So write like that, reactant or product, or just write like left and right, or the R and P, whatever you're convenient. Then write the number of each element before the balancing in the left side portion, and write the number of each element what you have in the product side or right side. Correct? So in that case, what we have here, forgot the red ink. Forgot the red ink. Do we have another line? Oh, okay. Forgot the red ink. So we have actually, before balancing, we have one molecule of nitrogen. That means two nitrogen atoms. We have one molecule of hydrogen. That means two hydrogen. But this is the after balancing. So just write the two hydrogen atom. And forgot about it. We have one nitrogen, forgot about it, just one nitrogen and three hydrogen. So now forgot about it. Let's change now color. Okay. So it seems that we have 2 nitrogen, but here is a 1 nitrogen. We have here 2 hydrogen, here is a 3 hydrogen. Here I want to share you something, the tricks. When you will see even and odd number, try to switch your even and odd number. That will help you to balance. For example, is here 3 hydrogen and this way is a 2 hydrogen, correct? So somehow, if we put the 2 here, we will have a 2 times 3 hydrogen 6. And automatically nitrogen will become balanced. Got it? So automatically nitrogen will be balanced. And finally, if we have a 6 hydrogen, as I say, even and odd, so we have a 2. So if we multiply here that with the 3, it will also 6. It makes sense, correct? So this is the tricks, as I said, that when you will start practicing, your each and every brain compartment will be opening how to first balance your reactions. So just follow this pattern. Do you guys understand this reaction balancing? So we had left side 2 nitrogen atom and 2 hydrogen atom. Right side, product side, we had 1 nitrogen and 3 hydrogen. As I said, that I'm not going to be balance the single molecules first, because any kind of number in the end I can add here because it will not affect other atoms. This is single molecule, correct? So that's why I thought that here I have a 2 nitrogen. Anyhow, I have to make it 2 in the right side. With that sense, I multiply this NH3 by 2. When I multiplied, I find that now I have 6 hydrogen, but in the left side, I have 2 hydrogen. So that means I have to add some number to multiply in front of hydrogen as a coefficient so that I can make it also 6. So that's why I told you guys that even odd sometimes helps you. So if you have a 6 here, it's very simple that you have 2. So use another even, odd number 3. 3 times 2 equal to 6. So this is the thing we have to do it during the balancing. See here the another example. This is the decomposition reactions. Even I want to mention it that sometimes you will find the chemical reaction that already balanced. Maybe you don't need to do anything. It's also possible. When we will see the practice sheet, we will find it. Now here, if you look into potassium chlorate, KClO3, this is a kind of decomposition reaction. So, you know, yesterday we were talking about the endothermic or exothermic reaction, decomposition reaction, breakdown reaction. So potassium chloride and oxygen form. So here we had one, we have one. We have here chlorine 1, we have chlorine 1. But the problem here, see here, odd and even. 3 oxygen and here is a 2 oxygen. So that's why I told that switch sometimes multiply with the coefficient odd even will help you to solve your job fast. So since I have to make it the oxygen same, so my job to make it same, so I will first add the 3 to the oxygen. When I will have a 3 to oxygen 6, so I will put here 2. So then I have a 6. So now oxygen is balanced both sides. And now I have a 2 potassium and 2 chlorine. So if I multiply the 2 in front of potassium chloride, then I will have a 2 potassium, 2 chlorine. But remember, this coefficient will not go with this one because this is the separate molecule by plus, correct? Yeah, this is try to make sure it. Now, this one little bit of complicated compared to some other one, correct? So we have here, you guys can see it. But now I'm going to ask you, let's do together when we will balancing these practice equations, then we will be done our 80% lecture for today's class. So first, then just we will go slide by slide. So let's go one by one. I think this one we already done, right? Nitrogen, hydrogen, ammonia. potassium chloride, potassium, we already done. Why don't we start from the 3? I will also help you, but I will suggest you guys to do either do on your computer or just take your paper page or do that. So let's start, because today's chapter is kind of, this is practice. If I make sure you practice this some example, I know that I have no problem. I will confident that I know that you guys got it. So let's try here. Sodium chloride and F2 fluorine. So we have NaF and plus Cl2. What I also can do, sometimes I give you guys access in the blackboard. You guys also can write it. Do you want to do that? You guys can also write here. But it's okay. You guys are too many students. Just do, and I will also help you. Yeah. Yeah. I think I got it. Let's hear from you guys. Anybody behind the students ask me if you see not clear. You need help. Let's do a little bit more bigger. Yes. Now we are doing here. If you're done, let me know that how you made it. Yes.
Oh wait, with the whole document?
Yeah, so let's tell me that which coefficient number you put here.
I put 2.
Okay, so I will also put, let's see. So here we go, the 2. Wait a minute. Okay, so here he put 2. Then
1.
here 1. Okay, here I want to say this is optional. When you have 1, if it's up to you that you will put 1 or not. Yeah, then?
And then 2. And then 1.
Yeah, I mean, that's it. So 1 actually, when you don't put anything, that means this is 1. So now look into here. He put 2 in front of sodium chloride or NaCl because we have 2 chlorine atom in the right side. So when he put 2 in the front of NaCl, he makes sure that he have now 2 chlorine atom in the left and right side. Now when he put 2, that means he also have a 2 sodium atom. So what he does, he has to make the same number of sodium in the left and right side. That's why he put 2 in front of NaF. Now what magic happened? Automatically, we had the number of 2 fluorine atom in the left side, and when we multiply by the coefficient 2 in front of NaF, we also have automatically 2 fluorine. So now if you look into the reaction, left side we have 2 sodium, right side 2 sodium. Left side we have a 2 chlorine atom, right side we have 2 chlorine atom. Left side we have 2 fluorine atom, right side we have 2 fluorine atom. So the reaction is balanced. Let's try the second one. Sorry, number 4. Oh, I think number 4 we done. Let's try the number 5. Yeah, now we will try the number 5. Yeah. This one. And here, before trying, I want to tell you, when you will see any group and the bracket and the suffix, that means you have to multiply this number to each element. So OH2 means you have 2 oxygen and 2 hydrogen. Okay, got it? Yeah, so now do that. I think I got it. No, no time. Anybody? Take the time. Yeah, you can tell me. I will write here. It's okay. It's okay. Yeah, right or wrong doesn't matter. Did you put any number here?
One,
Okay, that's great. That means nothing. I will move on then.
two, one,
And here,
two.
yeah, 1 means nothing. I think she does a great job. The reason we have 2 chlorine atom here and we have 1 chlorine. So anyway, we need to make it 2, 2, correct? That's why she put 2 here in front of HCl. So when she put 2 in front of HCl, now the next job come to count the hydrogen, correct? So we have here 2 hydrogen plus now we have 2 times 1 hydrogen equal to 2 hydrogen. So 2 plus 2 equal to 4 hydrogen. So now if we look into 2 times 2 hydrogen equal to 4. So that means chlorine and hydrogen is balanced. Now finally the terms come for the lead. Now if you look into the lead, we have now 1 lead here, we have now 1 lead. And also not final, oxygen. We have 2 times 1 oxygen equal to 2 oxygen, and here we already have the 2 oxygen. Got it? Guys, got it? Anybody have still confusion? Ask me. Why you have confusion? Sorry, got it? Okay. Let's move on. Yes.
What's in the parentheses means that they're both 52. Like
The bracket, parenthesis,
I mean,
yes.
they both 52, like they each.
Yes. So, for example, if you have a OH parenthesis and in the bracket 4, that means if not this subscript 2, just consider this is 4. That means you will have a 4 oxygen, 4 hydrogen. It can be any kind of element. Yes. Yeah. So now let's go move on to the 6. Because for your course, if you just make sure that you know how to do this couple of, then you will have no problem for your homework or final exam or lecture exam, because you will have question and this is a solid question. If you do, you have full points. Here I just want to make sure, look at here we have a polyatomic ion as a group, sulfate and sulfate. So here you can think as this sulfate group is 1 and here we have sulfate group 3. See the parenthesis. That will make your job easy. But before you, anybody else finish this one? Yes. Yeah. Here too? Okay, let's write here too. 6, huh? Yeah. It seems, let's now count. When he put 2 here, he find 2 aluminum. He think because right side we have the 2 aluminum. So now the number of aluminum is balanced. Second, the bromine. Once he put the 2 in front of AlBr3 or aluminum bromide, 3 times 2 bromine, 6 bromine total. So anyway, he needs to make it 6 here too. That's why he put 6 here. When he put 6 here, now the potassium is 6. But left side we have only 2 potassium. So again apply the even odd times, kind of coefficient. So he put 3 here, ultimately 3 times 2 potassium equal to 6 potassium, and he find the 3 molecules of sulfate that actually we have here. Now guys got it? Yeah. Now let's move on. I think we already done the 7, we have already. So let's move on for the 8. By the way, any question in the number 6 balancing? Have anybody? Okay, so let's move on for the 8. Got it. I got it. Now let's see what you got it. Yes, now you yeah, you will tell and I will write. Okay, so just tell the number from here in front. Oh, sorry, this is 8. Yeah, 1, 10, 5. Okay. Then yeah. So it is suggested here in this particular we should start with the hydrogen, because we have 8 hydrogen here and in the right side we have only 2 hydrogen, correct? So when we multiply with the 4 in front of water, we find the 8 hydrogen and its balance. Second option, you can choose oxygen, but the problem, if you choose oxygen, but we also have to consider carbon, because we have a carbon number of carbon 3 in the left side, but we have the 1 in the right side. So that's why she put 3 in front of carbon dioxide or CO2. So she makes sure that she has now 3 carbon on the left and right side. So finally, you can count the number of oxygen in the right side. Right side, we have a 4 times 1 oxygen, the 4 oxygen, and 3 times 2 oxygen, that's a 6 oxygen. So total, we have right side 10 oxygen. So that's why you have to put here 5 and make it 10, and your job is done. You know, it depends. For some student, it will take 1 minute. For some student, take 5 minutes. Even it can take 10 minutes. But no, don't give up. This because you will have a couple of questions from this topic and this balancing. And not only here, you may have to take the more chemistry course. So always you go to the laboratory, you do some chemical reaction. It must be. It is a requirement that when you write some chemical reaction, please write your balancing form. So it is very basic things in the chemistry to learn and practice it. So let's do now 9. Yeah, this is little bit of, you have to use the advanced knowledge, but still it's okay. I will explain. First, I want to see that somebody do it or not. Anybody? You can take your time. Yes.
Okay, for the first one, I put 2.
You got it. Yeah, you got it.
2.
Yes.
Then I put 25.
Huh?
For the all 2, I put,
Here?
yeah,
How many?
25.
25?
Yeah.
Okay, let's see. Yeah, 25.
Then I put 16 for the CO2.
Okay.
And then I put 18 for the H2.
How many?
18.
18?
Oh, 18. Yeah.
18?
Yeah.
Why 18?
No, 18. 1 8.
Here?
Yeah.
Oh, okay, okay, yeah, okay, yeah. Then let's count down. So he put 2 in front of C8H18. The purpose, because if we put 9 into the in front of water and could make it 18 here, it go to the number that we need to use the fraction here. That's why we don't like the fraction. That's why we make it little bit of more easier by putting 2 coefficient in front of C8 and H18. So when we put C8, H18, that means we have 16 carbon and 36 hydrogen. Since we have here 16 carbon, we need to make it here 16 carbon. That's why she put 16 in front of carbon dioxide. So now we have the balanced carbon, but we need to balance the hydrogen. and oxygen. But here oxygen should be considered finally, because oxygen we have in the two molecules. So when we are going to balance the hydrogen, number of oxygen will be changing automatically. So this is not an intelligent way that second choose the oxygen. So now second, if we choose the hydrogen to balance, we have 18 times 2, 36 hydrogen here. So obviously that's why we need to put 18 times 2 hydrogen here. So 36, 36. Now let's count how many oxygen we have. So we have 16 times 2, 32. Yeah, that's why he got the 50 oxygen there. And we have 18 times 1, that means 18. So 32 plus 18 equal to 50 oxygen. And that's why he put here 25. Got it? This is little bit of more time consuming, but you need to see that when you will see that you don't have you have a fraction. So this is the common way to think one more coefficient times, so that you can make it balance, not as a keep as a fraction. Because if you now think that if I could put here 9, yes, we put 9, we could maybe also balance, but here we could come something how to say 9 times 9. So we need to multiply here 4.5 or something that we don't want. Like that, maybe it would come. So that's why when you will see this type of, yeah, you need to be little thin and you need to be balanced like that. So now we don't have too many more. 9. Let's do the 10. I'm doing because I know that if you do here, it will be helpful for your homework and exam and everywhere. You have a quiz, and we will go back to our lecture slide. It will take so easy now once we do that. Here you can consider the OH, polyatomic ion. So here T the 1 group functional, and here we have 3. That will help you to do your job easily. Yeah, number 10. First, consider chlorine to balance. Yes, you did it, but I want to hear also from some other students. So can you tell? Yeah. This one, number 10. Okay, so I will write. So first you write here 3, correct?
1.
1? Okay, oh yeah, yeah, 1. Then 3, okay. Then 1, okay, then yes. So he put here 1 because he first want to balance the number of chlorine. So we have 3 chlorine here, we have 1 chlorine. That's why first he put 3 here, make it the 3 chlorine balance on the both side. Next, we have the 3 sodium now, but this way we have 1 sodium left side. So anyway, we have to make it same. So he put 3 in front of NaOH or sodium hydroxide. Now, automatically you can see that we have 3 hydroxide group in the right side, and here also now we have 3 hydroxide group. So the reaction is balanced. How many we have? We have 20. Okay, let's do 2 more. You guys can practice later. Let's do 11 and 12, and then we will go back to the our lecture. So here what you are going to do. Yes. Here is 2. Think little more. Yes.
It's going to be 4T.
Yes, that's correct.
502.
Yes. Yeah. So when you put the 2 here, that means we have 4 phosphorus and 10 oxygen. Yeah, that will make your life easy because you don't have to be fraction here. In that case, phosphorus is a single element. So that's why we will balance phosphorus last, because we can put any kind of coefficient number in front of phosphorus, correct? So that's why in this particular balancing of reaction, we did not consider the phosphorus first. Now question?
Yeah, on the slide, it's not like it was point something, 0.5. So am I not to use like a 2.5?
Yeah, that's, I mean, even if you got the 2.5, our chemistry rule said that if you have some fraction 2.5, 3 point something, so next you have to do one step more. I mean, choose some types of number so that you can multiply each molecules and make it those fraction as a whole number, full number. So that's why I'm telling that if he put 2 here, maybe we could find the 2.5 oxygen. So basically the same. Next step, we need to do the multiply with 2 to phosphorus, multiply with 2 to 2.5, and multiply here 2. So ultimately the result comes the same. Yeah. So you guys can practice here. Now let's go back to our topic 5. I mean our slide. This one. Yeah, so this was the just, let's go back. It was from the electronegativity summary we already talked yesterday. So I'm going to directly go for today's topic. Yeah, same slide that we talked yesterday. Yes, let's go here. Now it will very kind of review it will be now. So now we will know the balancing of equation and everything. So now our topic 5 is also telling the same thing, the chemical equation, as we all know now. So let's go for a review. Like for example, the burning of magnesium is an example of chemical reaction. So not only magnesium, our each home have the alumina foil. Correct? Alumina foil we use for the wrapping purpose. Alumina foil is also the same reaction. When we do cooking, sometimes, like in my house, sometimes I use the alumina foil to cover the stove because every day I cannot wash it. So sometimes I use the alumina foil so that I can just wash the alumina foil. So you will see that if you do the alumina foil come close to the fire, it's burning. That means alumina foil, magnesium foil, they are reacting with the oxygen and producing the magnesium oxide. Now the same thing, that it is very longer to tell and always write in a sentence like magnesium is burning and producing oxide. So in place of that, if we write the chemical reaction, this is more clear, more understandable, and more visually appealing. So that's why we use the shorthand representation of the chemical reaction by using the symbol of element or molecules. And that's why we say this is the chemical equations. Balancing the chemical equation, we now know mass of conservation, that atom cannot be created nor destroyed, just can be changed or combined with other atom to form the new molecules or compound. Okay. Now we know the balancing, so we can skip here. This is very easiest one. Here, another example for the chemical reaction, and also their title telling that predicting the molecular formula. Okay, let's consider the burning of aluminum in oxygen. I just said, so aluminum plus oxygen. Aluminum foil is the practical or day life example. That's why I told. So this is solid and oxygen is gas. So what happened? Let's write also here because it will help you to practice formula too. So here, when you will write any formula, you know let's forget you don't have this one because you also need to write. You know, I uploaded practice the formula one attachment, the table. I will show you how to practice it. Then it will be helpful also for you. Like we know the symbol of aluminum is Al, and we also know the oxygen. But normally this is not an elementary oxygen. This is actually oxygen molecule. So it will make the aluminum oxide. So we know the aluminum symbol and the oxygen. Now, like one student always 2 times came to me, she was confused between the crisscrossed charts. When we write the formula, two things we need to consider, or two types of rules. First of all, if you use the crisscross formula, that means, for example, aluminum charge or metal charge will go to the right one as a prefix, suffix or prefix, we say that down, suffix, huh? Or prefix, I sometimes confuse. And here the oxygen charge will go to here. So in that case, we know the oxygen charge or valency is -2 and the aluminum charge is +3. That's why this aluminum charge will go to oxygen and oxygen charge will come to aluminum. Now first I will delete the annotations. So now I will ask you that if you need to find the aluminum charge in this compound, you don't need to look into the aluminum. You need to look into the oxygen, because aluminum charge we write here as a 3 suffix, correct? And oxygen charge we write is aluminum suffix or down. So this is our rules of writing formula. Got it? Last time we also talked, and you have to follow actually most of the time same. There is some exception, like yesterday she was asking me the vanadium. Yeah, that's the exception. Sometimes if we have a more, like this side is 2, this side is 4, we can make it simplify and write 1, 2. Like last time vanadium had a 8, so they write, I think that it's supposed to be 2, 8, and maybe they write 1, 4 or something. That sometimes, that is some exception. Other than that, like lead for oxide. Other than that, we always follow this rule, and there are some exceptions, mainly comes for the transitional metal, because they have a multiple valency, like copper 1, 2, lead 2, 4, like tin, stannous, couple of. Otherwise, you always have to follow that rule. So if you know how to write the formula, that means you can also write the chemical equation from the sentence to the reaction form, correct? So now when you know how to write the aluminum oxide, now you have to balance it. And here it's very simple that we have 2 aluminum and 3 oxygen. It is a common sense to apply odd or even number. Like I have here 3, I have here 2. So now I'm not going to balance aluminum first, because aluminum is I can balance anytime. So what I'm going to do, I'm going to put here 2. So 6 oxygen, I will put here 3 to 6 oxygen. So finally we having the 4 aluminum, so I will add here 4 aluminum. So this is how you have to move on. The balanced chemical reaction, same thing. Now we are not going to here, but we are going to talk here the stoichiometric coefficient or equation. As I said in the beginning, that what represents the balancing of chemical reaction. Balancing of chemical reaction represents that the number of moles in each element or molecules we need to start the reaction, and we can predict that how many moles or molecules of reaction we can get as a product, and we can make the ratio for that, because when we start the reaction, for example, we need to do this reaction. So aluminum plus oxygen. If we don't know the ratio of oxygen, the ratio of aluminum and oxygen from this coefficient looks 4:3. So if we need to start this reaction, at least we have to give the 4 mole or molecules of aluminum plus 3 molecules of oxygen to start the reaction and produce the 2 molecules of aluminum oxide. Now you can ask me that I don't need the 2 molecules of aluminum oxide. I need only 1 molecules of oxide. So you can easily just decrease the amount of reactants, correct? So here, if now I say that no, I don't need to make the 2 molecules, I will make the 1 molecule. So if I now make the 1 molecule, so here I need 1.5 molecule and here I need 2 molecule. Make sense? Yeah, that's why this balancing of the reaction is also important in terms of stoichiometric coefficient or equations and when we need to start any chemical reaction. And that's why we always need to do the balancing of equation. And subscript in the name of a molecule, these are part of the chemical formula. These are never changed when balancing, because it's a kind of part of formula. We cannot change the subscript. So we have to be keep in mind and we need to move on for our balancing or reaction. Yes.
So we're allowed to use fractional molecules.
I mean,
if we only
you know, legally, if anybody writes the fraction, we cannot say to you this is wrong. But since this is always inconvenient to calculate and count, we prefer that try to be make it whole number. Even honey, if you write the like fraction, you need to just do the extra step more, as I say, to make it whole number. And this is actually already advised in the book, chemistry book. So if I cannot say this is wrong, fraction, okay? But this is not convenient. That's why we try to be make it as possible as a whole. Now let's do the example together. So in that case, we have C2H3Cl liquid and oxygen gas. This reaction produces carbon dioxide, water, and HCl. Write the equation using the chemical formulas. We have this equation. Count the number of atoms on either side. Okay, so they're asking it for just balancing of this reaction. Could you guys balance? I think this is already balanced here. So let's move on and just see, because now we know how to do that. So in that case, if you look into the particular reaction, what we have here? Carbon 2, we have carbon 1. We have hydrogen 3, we have hydrogen 3 here. We have oxygen 2, we have oxygen 3. That means we have to do something here and here, otherwise we cannot make it. Because if you make it here, add the 2 here, then we will find here the 2 carbon and 2 to 4 oxygen. But still we have 3 hydrogen. That means we will put here 2 hydrogen. Let's do that here. So if we put here the 2 and then 2 carbon, 2 carbon, in the same time we have to make it all down. See here? Then this is the thing that we were talking. So now that means we have to think a little bit of extra, because we have here 3, we have here 2. So what we could do, we could put here 2, we could put here 3. First, correct? Forget about this. So then we have 6 hydrogen, we have 6 hydrogen, correct? So now we have to mention the 4 carbon. So let's put here 4. So we have now 4 carbon, 6 hydrogen, 6 hydrogen. Yes.
So isn't it, I think hydrogen was really balanced. Isn't it because it's H2O plus HCl, so it was really good hydrogen?
Sorry, can you tell once again? Oh, we have one more hydrogen here. Oh, sorry. See, no, that was my things. I didn't focus here. Okay, so let's start with the new thing. Thank you. So let's go here. So we have here 3 hydrogen. Oh, we have here. So let's forget about it now. Then let's make it now 2 carbon, 2 carbon. So beginning I was correct. Then my focus was not here. So 2 carbon, 2 carbon. Now we have 3 hydrogen. So now we have chlorine, correct? So 1 chlorine, 1 chlorine. But still we have here 5 oxygen. So that is the point will come here. So 5 oxygen means like that. 2.5. Now got it? So in that case, we have to do one more times to make it whole number. And that actually I was talking, and this is the example of the reaction. So now let's go on. So first, if we do like that, this is our situation. So next, go back to here. See? Determine how to make the number of oxygen atoms equal to reactant or product. So we make it here same. Now let's go to the. So we have now see the same number, but the thing is that write the equation using chemical count the number of atoms and begin balancing. Okay, we multiply everything by 2 to keep the ratio same. Now you get it what I was trying to say? This is the example. So sometimes we will find the fraction, but ultimately it is not convenient. So we have to add one more step to multiply with some other number so that we can make the whole number ratio. So this is the example of that. Still I'm telling that the fraction is not legally wrong, but this is inconvenient. That's why in that case we guys do this type of situation. So that's why initially I thought it will 2, then I start with 4, then I was confused because here is one hydrogen, but ultimately this is the scenario. So if you are confident, beginning you can do the last step, then you don't need to do the exercise step more. And if you think that I will just go with the regular rule, so you need to do just the one step more. Identify the balanced chemical reaction or equation for the reaction that occurs when gaseous nitrogen monoxide, that means NO, decomposes to produce gas as dinitrogen monoxide and nitrogen dioxide. So can you just guess? I know we have here. However, it seems the number A is the correct between the 4. This is a kind of question that is going to be have into your exam, because normally during the lecture exam we try to keep it multiple choice question for the convenience. But other than that, like recitation quiz, sometimes I just do that and we grab the point. So this is the example of A. So you guys need to do, you can take the scrap paper and you guys can do and you guys find the answer. We have also here some, same, I think some we already do it in our practice sheet. So I think now you find the many examples of that type of things. Yeah. Chemical reactions are represented by the equation. Yeah, that type of things now we all know. We done practice our job. Here, let's little bit of talk. Give us a recipe for a chemical reaction. The ratio will always be constant for this reaction. How many molecules of oxygen are, yeah, that's the math, stoichiometry equation and math. So, as I said, that this reaction representing us, that telling us 2 molecules of hydrogen is reacting with 1 molecules of oxygen and producing the 2 molecules of water. Now, if I ask you, well, first of all, I want to tell you the ratio. What are the ratio? Ratio can be hydrogen and oxygen between. Ratio can be between oxygen, I mean reactant and product. So oxygen and hydrogen. Even ratio can be hydrogen and water. Any kind of ratio you can be, correct? The ratio of hydrogen and water 2:2. That means 1:1, correct? If we simplify. The ratio of oxygen and water is 1:2. That means 1 molecule oxygen need to react with 2 molecules of hydrogen and 2 molecules of water will produce. So at least you need 1 molecule of oxygen to start this chemical reaction. Now the question you need to learn, you need to learn and you need to do during your exam, that I can ask you different types of ratio and you need to calculate and make the answer that how many mole actually we need for particular ratio. For example, I can ask you, give you this reaction, and then I can ask you that how many molecules of oxygen are required to react with 2 molecules of hydrogen. So you know it's very simple, the oxygen and 1 molecule and 2. So you know that 2 molecules of hydrogen we need the 1 molecule. This is simple, but now if I ask you how many molecules of oxygen are required to react with not 2? Let's ask you first 4, easy one. So you will just increase the times, correct? But if I ask you, can you tell me how many molecules of oxygen are required to react with 4.5 molecules? So you just need to do the math, little bit of complicated way. So that's we are going to try the next also. So this is how, if you have the standard chemical reaction balance, you can calculate the any kind of ratio you need. Building intuition reaction ratios, just I said. So the ratio of hydrogen and oxygen 2 to 1. Now let's see here the 16 times half. 16 times half in that sense because the atomic mass, weight of the oxygen is 16. So this is how, like atomic number is 8 and atomic mass is 16. So we can calculate the quantity from the ratio and above from the knowledge of our atomic mass or atomic number that we already have in the periodic table. So we can predict the amount of reactant that will react and the amount of product that will form. So we can find the ratio, even we can find from the mass in gram. That's called the mole actually. We will be talking here. So you can see here the ratio of hydrogen to oxygen is 2:1. So 2:1 means 2 molecules of hydrogen need in context of 1 molecule oxygen to form the 2 molecule of hydrogen. So now 2 molecule of hydrogen but 1 molecule of oxygen. That's why they multiply by the half. Here is also kind of thing we need the conversion factor. You remember that which unit we need to do, write the top. So here which ratio or we need to find the mole, we need to write the top, and if we do the existing number, we will find the same value. But I also have some other rules for that, so I'm going to show it. So first, let's see here. The ratio of hydrogen to oxygen is 2:1. So here is 244. Where they get the 244? I really don't know where they got the 244. Yeah. Yeah, these things I need to little bit of check it out. Combining ratio in context is okay. Yes.
This is all like the atomic mass.
But don't you think this atomic mass is kind of bigger if you consider, because oxygen is, if we see the 16 plus 2, 18, and for the 2 mole it's going to be only 36. So for me it may be they times more times, that's why they come, but I will check it out and I will explain you by the next class. Yeah, this one I will check it out and I will explain you, because I have some other rules how to do that math. As I said in the example, here we go. Like 4 mole is easy, but when it will come more, like 16.5, this type of, you need to do the calculation, correct? I have the simple things that I will share with you the next class, yeah. And I need to actually check it out why they write here this big number. Yeah, because this is not so big number, the mass, yeah. So this one I will be checking out and I will let you know the tomorrow. But here, how many molecules of magnesium sulfate are required to completely react with 36 molecules of sodium chloride in the following unbalanced reaction? So here, first you have to balance the reaction and then you have to find how many mole you need. As just we talk. See here, if we balance the reaction, this is our balancing of reaction. Now they are asking, we have 36 molecules of sodium chloride in the following unbalanced reaction. How many molecules of magnesium sulfate are required to completely react with 36 molecules? Okay, so now you can see here 36 molecule of sodium. Okay, now we have here 2 molecules of sodium chloride, correct? So for 2 molecules of sodium chloride, we need 1 molecules of magnesium sulfate. So now they are asking for the 36 molecules. So 2 for 1. So for the 36, it will be 18, correct? Yeah, so as I just said, see now here, yeah, this is I was talking actually, this one I was talking that, sorry, you need to know this one, then you can calculate any amount. Yeah, this one. And this is kind of the same, the conversion factor we have learned in the last class, last time in the topic 3, I think. Here just the difference is that in the measurement, we use the standard unit, and here we will use the standard information from the balanced chemical reaction. Got it, the difference? So we have the 36 molecules of sodium chloride. We have to count the magnesium sulfate. So we need to write the conversion factor ratio between the magnesium sulfate and sodium chloride from the balanced reaction. So that means our job will be here like that. Magnesium sulfate, yeah, that was that I was talking, that we should learn first this one. And the sodium chloride, the ratio 1:2. So now we have 36 molecules of sodium chloride. So we have to just multiply with the things. So 2 times, 18 times. And this is also sodium chloride. So this sodium chloride nullify, you will have the answer. Got it? And this is the same as the talking that first we need to know this one, then we can find for any other ratio. And that's why last 2 slides was little not convenient for me. That's why I told that I will check and I will explain. So now I think we got it, the things. Let's move on the another one. Okay, in this reaction, nitrogen combining the ratio in context. We come in a dozen now. One nitrogen molecule reacts with 3 hydrogen molecules to produce 2 moles of molecules of ammonia. 0.5 dozen nitrogen can react with 1.5 dozen of hydrogen. And this is just little bit of fun and give you the quantitative idea, okay? Nothing else. So in terms of molecules, they just write the dozen. Got it? So it's very simple. We already show you that for 1 molecules of nitrogen, we need 3 molecules of hydrogen. So obviously for the 0.5 or half, we need to reduce the amount. Correct? That we already talked about. This is important? Yes.
I mean, what is, isn't it just, 0.5 dozen, like six, um,
No, 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 no.
what
Point
exactly
5
is
is
dozen?
less than 1. You know,
Yeah.
0.5 is less than 1. So for 1, we need 3.
So what is a dozen?
Dozen, dozen, they just give you as an example. Like we say the molecule, they just a dozen. Because normally dozen we use for the banana or something like that. This is not the chemistry term, correct? They just give you as an example. But here, if you look into the amount and share, this is the thing. That if one molecule, for one molecule nitrogen, we need 3 molecule hydrogen. For 2 molecule, we need 6. Now you got it the calculation. For the 1, you need 3. It's simple. Okay, let's see. You can buy 3 ice cream with the $1. So how many ice cream you will buy with the $2? Yes. Now if I ask you don't have a dollar, you have only 2 quarters. So you can buy 1.5 ice cream. If the ice cream company gives you half, pattern like pizza slice, they give us as a slice, correct? But ice cream don't give us. So like that. This is not complicated. Please don't be confused. Yeah, because we are learning so many things. I also don't want to make you complicated. So this is the things here. Stoichiometry equation is kind of ratio. So here simple. Just consider that nitrogen is a dollar and hydrogen is an ice cream. So $1 you can use and buy that 3 ice cream or 3 hydrogen ice cream. So many different ice cream, right? Now, banana ice cream, fruit ice cream, chocolate ice cream. So let's think the hydrogen ice cream. So you can spend the one nitrogen or nitrogen terms of dollar. So $1 for the 3 ice cream. So 0.5, that means 2 quarter, 50 cents. 50 cents for 1.5 ice cream. Like that, okay? So that's why I also saw when I saw yesterday and I was smiling that why we need to take into the dozen in the chemistry, but it's just too easy understanding, nothing else. Given that nitrogen react with hydrogen to produce ammonia, and see now let's see here. As I said that the simple equation you can do just orally, but when you have the different term, you have to just do the math, and math is same as the conversion math. You have 14.5 dozen molecule of nitrogen. Just consider as a dollar or molecules we talk. How many dozen atoms of hydrogen are needed to completely consume the nitrogen and produce the ammonia? So now let's go back our job. Ratio of nitrogen is 1:3. This is clear. Now 14.5 molecules of nitrogen times 3 molecules of hydrogen divided by 1 molecules of nitrogen. We have the ratio for 1 and 3 for 1 nitrogen molecule, but we don't know the ratio for the 14.5, correct? That's why if we need to find the ratio of nitrogen, 14.5 molecules of nitrogen to the hydrogen, so we need to find out the same conversion factor. And we know that we have the nitrogen, we have to find the hydrogen, correct? So that's why we need to compare in the context of this ratio. 3 mole hydrogen divided by 1 mole nitrogen. So now I want to show you, do the calculation, it will make you easy. So this 1 mole nitrogen, this 1 molecule nitrogen nullify. What we have then? 3 times 14.5 molecules of hydrogen, that means this one. Is this, you guys got it? This is the last because today we learn nicely, so I don't want to complicate it. So this is our last problem. Next class we will complete this and we will start the topic 6. So now you got it the ratio. We can orally also talk it. For the one molecule of nitrogen, 3 hydrogen. Same, again talk the same. For the $1, 3 ice cream. So however with the $14.05, how many ice cream we will find? The hydrogen ice cream. So for the $1, we find the 3 hydrogen ice cream. So if you have $14.50, how many ice cream you can buy? Hydrogen ice cream. That's tell me, and this is the odd for today. $1, 3 hydrogen ice cream. So I give you now $14.50. I ask you, you cannot deduct me any money. So how many ice cream you can buy for $14.5? It's very simple. For the $14, I will buy 3 times 14, so 30 and 3, 42. And for the 50 cents, I will buy 1.5. So 43.5. I think so. Simple. And that's all possible.